كده انا بريكورد دلوقتي.
خلاص داني، يعني مفيش مشكلة معايا.
كده تمام.
ممكن بقى عبد الرحمن تبعت اللينك.
خلاص حاضر دلوقتي.
So good evening. Hope you are all doing well. I'm Hadi Ali. I'm a senior student of petroleum engineering at Cairo University and a technical officer of SPE-Cairo student chapter. I'll be moderating today's session. Our session is the first session of the course titled Stack Pipe, presented by a proficient speaker with an extensive experience in oil and gas industry. I'm sure that his participation will benefit all attendees. So please join me in welcoming Engineer Mahmoud El Husseiny. Engineer Husseini is drilling engineer and rig supervisor at the Egyptian Natural Gas Holding Company, EGAS, with 7 years of experience. He holds a master and a bachelor's degree in petroleum engineering from Al Azhar University in Egypt, and a master's degree in business administration MBA, jointly accredited by Autonomous University of Barcelona in Spain. Also, he holds a professional diploma of strategic management from Missouri State University in USA. Prior to working for EGAS company, Engineer Husseini worked with Petronil Eni, BP, Dana Gas, Wasco, Sea Dragon, and Edison Abu-Qir petroleum companies on a challenging well that induced HBHT, MBD, stress caging, cake loss cycles, severe mud losses, and ballooning conditions. Moreover, Engineer Husseini published 3 international papers to articulate some of these challenges. His expertise covers the Nile Delta, Gulf of Suez, and offshore Mediterranean in exploration and development campaigns, including drilling and workover activities on semi-sub, jackup, and land rigs. On final note, if you have any question related to the technical content of the presentation, please leave them in the chat box and Engineer Husseini will answer them inshallah. And now, Engineer Husseini, the mic is yours.
I'm so sorry. I was on mute. I'll start over again. Now I think the voice is working. Please confirm. Could you please confirm if the voice is okay? Okay. So thank you so much, ENG for the introduction. I'm so glad to be with you today and over the 3 days of the course. Just a small note in the intro. ENG said that previous or before working for EGAS, I worked with IPP extra, but that was while working for EGAS. It was like a loans or a assignments while working with eGas. That's just a small note. So the stuck pipe, we'll speak about the stuck pipe. What's the stuck pipe at the first place? A stuck pipe is unplanned stall or unplanned restriction of the drill pipe or the casing string in any phase or any stage in the while drill. So it's unplanned. It could be I could lose the movement totally or partially, and that restrict me from retracting the drill string or the casing string. So what do you expect to know from this course? First thing, you will understand and identify the situations that could lead to a stuck pipe situation, stuck pipe event, and also your knowledge about the preventive measures that should be taken to avoid such occurrence will be covered. Your knowledge will be improved in this area, and have the confidence in the first action, what to do at the first sign of stuck pipe. So we will cover in this course three main sections: the solid induced backoff, differential sticking, and mechanical and wheel geometry. These three categories are the main stuck pipe mechanisms, and each one have sub items, and we also will speak about each of them in details. What we're gonna cover the description of the event, where it's more commonly to happen, in which area, drilling which formations, in which situation, and we'll know how to prevent this event from happening, and then we'll know the rig site indicators of a developing stuck pipe situation. And finally, we will know how to free and how to alleviate such a problem. So, first of all, at the beginning of each section, I will give a general first action instructions, and later on, part by part, I will refer to this section, and if there was a modification on it. Just be patient. There is a lot of new expressions will be mentioned, and that's why I want you to be patient and to be ready to go out of your comfort zone. You will hear a new information today. What I want you to do, take notes. Ask me in the chat box. Google the information after the session. I will also send to the moderator like reference material. Today you can like extra read more about the topic or what we mentioned or cover in the session. So one by one, step by step, you will get out of your fear zone to the growth zone, but that's through learning zone. We should put some effort. We should expect to hear things that we don't know. Don't be afraid to ask. There is no question such stupid question. That's what I'm expecting from you. So the stuck pipe has always been a problem, a major problem of the drilling industry. It cost us millions of dollars since its first consequence is non-productive time. I'm hiring staff, service companies. I'm hiring a rig with a daily rate, and I do nothing I'm just solving the problem. So that's a lot of money. And understanding the basics that we will discuss today and communicating well with each other in the drilling crew, knowing the prevention actions that should be taken, and be vigilant about the indication that might alert me that something wrong is gonna happen, and our rapid response that will lead finally to reduce the cost of stockpile. So in the first section, and that's the first type of or the first category of stockpile events that we will cover today, is the solid induced backoff. That's mainly caused by the accumulation of the solids around the drill pipe, and such solids will be produced from the formation with various forces and various reasons, as we're gonna discuss. We will discuss in this section 8 types of solid induced backoffs: the unconsolidated formation, mobile formation, fractured and faulted formations, naturally and induced overbalance, overpressure, collapse, reactive formation, hole cleaning problem, and tectonically stressed formation. So in this section, in case of any of the eight events happen, we have a general first response, a general first action. Our first action, in case of the solid induced problems, I will turn the pump off, reduce the pump speed to half. Sorry. The first sign of such a problem is increasing in the torque. That means that the drill string is not freely rotating. And the torque is the first expression we mentioned today. The torque is a torque, but the physical meaning of it is the resistance of the drill string to rotate. So if it's freely rotating, the gauge will be at the black mark here. That's the free life torque in normal situation. Nothing is happening. Once the cuttings accumulated and prevented or partially prevented or partially restricted the annulus, the torque will increase. That's the first sign of the drill string torquing up. So the first action, or the first step in my first action, is to turn the pump off to the half of its speed. So I have here a stroke per minute, which is an indication of how fast, how many strokes the pump is doing, how much I'm pumping inside the drill string. So if I'm at 150 strokes per minute, I should have that number to 75 strokes per minute. So the first thing to do is to reduce the pump speed to the half, and that will help in reducing the pressure that's trapped here. Imagine that the annulus is packed or partially packed, so and I'm continually pumping from the string to the annulus. The pressure will build up here, and this pressure will aggravate the situation, will make it worse. It will worsen it. So the first thing to do is to turn the pump off to its half rate to reduce the pressure that's trapped. So if the hole cleans up, if that action, the first action or the first step of the action, solve the problem, I should return the flow rate to its normal rate and clean up the hole before doing any further drilling or tripping. If that doesn't happen, or if that didn't happen, so I will immediately stop the pumps and bleed down the pressure. So the first action is reduce the rate to the half. If that doesn't solve it, I will turn the pump off, completely turn the pump off, and bleed off the pressure that's trapped here, but keeping 500 psi, only 500 psi, as we will mention in the next slide. So if I have an unported float valve in the string, I cannot do so. And that's a new equipment, a piece of equipment, and a new expression we mentioned. The float valve, we normally, that's like a standard. We insert it above the bed, and it's used as non-return valve. As you see, it allows the flow to go in this direction, but if the pump turned off, it will close and prevent the U-tube. We have two types of such flow valves. One is ported and one is non-ported. One have hole or two holes in this flapper wing or in this piece, and one doesn't have. If we have the solid one, we cannot bleed off the pressure. So we will skip this step if we have an unported float valve. And we need to be patient while bleeding off the pressure. Like, imagine we have like a stable pressure system here, and I'm pumping through the drill string up to the annulus, to the rig floor, and suddenly or like gradually the annulus are backed off. There is a restriction here to totally backed off. So now I have a pressure here that's not allowed to be bleed off in this way. So in this step, I turn the pump off and bleed off the pressure. So I need to be cautious while bleeding off the pressure to prevent the U-tube effect. If I bleed off suddenly, the cuttings will enter the bed and plug it. The U-tube will happen and enter the cuttings in the bed ports, which will plug it. So that's something to be taken care of to bleed gradually. So after that, as I said, we will not totally bleed off. We'll leave 500 psi on the standby pressure, and I'll use them as an indicator if the problem continues as it is or there is an improvement in my situation. If I'm keeping 500 pressure here and I can see them and monitor them on the gauge in the surface while working or applying the next steps that I should be taking, if the problem is solved, some of this pressure will be bleed off, and I will know and notice that in the surface. So I'm keeping it as an indication, as a monitoring tool to what's going on down there. So we will leave 500 psi trapped and monitor what's happening down there by looking at the gauge. So my next action is torque the string. We know that we can move the string up in the normal situation, up and down, and it's continually while drilling, it's rotating. So now it is stalled. It's like jammed. So in this stage, after turning the pump off and bleeding the standby pressure, keeping 500 psi on the standby gauge, I will take a further step and start torquing the string. Torquing the string, like moving it, like forcing it to move. And there is a limitation for such action, since all the parts of the drill string has a maximum torque limit, has a maximum weight limit, the maximum weight that they can handle, and maximum torque. So I will not exceed the maximum torque that the weakest part of the string can handle. And this number should be known for everybody on the rig. Our maximum torque is this value. We cannot torque up more than this unless the string could be parted. So now I will try to torque and release the torque. So cycling the torque on and off, like trying to rotate the string and relieve it again. Rotate it to the maximum and rotate and relieve it again. And we should hang the string at its free rotation weight, and that's a new expression we will hear in the rig. So what's the free rotating weight? So commonly, and it's a drilling practice, that before drilling any new formation, I should take the free parameter. We call it free parameter. So these parameters will be used as a guide. So I will use such parameters as a reference to my operation. So a normal operation, that's my parameters. If anything changed, that means there's something going wrong. So I will have the pressure at this flow rate. So I know normally the pressure is, let's say, 600 psi, 500 psi, 1000 psi. So that's the normal parameter. That's a free parameter. So if this pressure change increased or decreased, I will notice there is something wrong. I might lose a nozzle in the hole if this pressure decreased. If this increased, I might have back off. I might have a restriction in the flow path. I might have a plugged nozzle. That's an indication of something abnormal is happening. So the free parameters, I'm using it as a reference to compare against in case of the problem. So the free rotating weight is the weight that I recorded while recording the free parameters, and I'm rotating the string, and it has a certain weight. So it will be different than the off bottom weight or no rotating weight. So the free rotating weight, and this is a number I already know during recording my free parameter, the free drilling parameters. So hang the string on the free parameters. The free rotating weight and apply torque and relieve it, apply torque and relieve it, which we call cycle torque. Cycle the drill string up to the maximum torque and release it, up to the maximum torque and release it, and the caution should be considered while doing so. We apply the torque gradually and release it gradually, not to back off, not to unscrew the string. So the fifth step, we'll continue torquing, cycling the torque, applied and relieve it, applied and relieve it, while, as we said, monitoring the standby pressure, the 500 psi that we keep holding on the pressure as an indicator, and also monitor the shakers, the return, what's going from going up from the well. Did the circulation started or not? And if I'm partially, I have a partial circulation. Is there any change in the return rate? So I should be continuously monitoring the shaker and the standby pressure. If a change happened in the pressure, which means the 500 psi decreased, that means that the problem is alleviating. I start solving the problem. The circulation start to happen. That means that I have a circulation or start the circulation. In this case, if that happens, I should compensate for the reduction in the 500 psi and monitor what is happening. If the 500, each time I compensate the pressure, it keep relieving, that means I need to increase the pump rate. And increasing the pump rate meaning regaining or return the circulation. So I'm keeping or initiating a circulation here, which means these cuttings will start to be suspended and be held to the surface. So at the first indication of bleed off, I will compensate. If this pressure keep bleeding off, I will increase the pump rate, or you should increase the pump rate and commence a circulation. So if the situation is still the same, so I'm cycling the torque, but there is no improvement in the situation. So at this step, I will work the string up and down to the free weight. So as we said, we recorded the free parameters. So included in this free parameters, and that's new expression to mention that, to be mentioned now, the free up and free down weight. So we know now there is a rotating weight, and there is a free up weight, and there is a free down weight. The free up weight is commonly referred at the rig floor or at the rig side as pickup weight. And the free down weight is commonly referred as slack of weight. So while before this situation happened, I should record. That's a normal practice. I should record the free parameters, and these parameters have a free up weight, which is the pickup weight, and slack down weight. So I will continue picking up and putting down the string, slacking off the string up to the free up weight and down to the free down weight, up to the pickup weight and down to the slack weight. So what I'm doing right now, I'm keeping 500 psi on the string, on the standby here below the back off. Keep cycling the torque, applying it and relieving it, and keep moving up and moving down, like or like tensioning the string up and put the weight again. Tension the string up and put away the weight. And there is a note here not to exceed or not to excessively pull the string up, so not to part or not to break the string, the drill string. So we need to put a limit, maximum 50,000 pound maximum, unless that will like escalate or aggravate the situation instead of solving. So, and in this stage, stage of solving or responding to a stuck situation, we do not or we should not fire the jar. So, and the jar is a new expression and a new piece of equipment mentioned here. What is jars? The jars, it has different like mechanisms of working, but the main concept, it gives you like a hammering effect. It gives you more power than you can apply up or down on the drill string. So imagine you have a piece of equipment that you can signal it or give it an order with different like steps or instructions or mechanisms that will give you a hammering power up or a hammering power down. So that's what jars do. So in this case, we should not fire the jars. We should not activate the jar. So we have more things to be done before that step. So even doing so, keeping the pressure, cycling the torque, moving the string or tensioning the string up and down, even doing so, though doesn't help in establishing the circulation. So we need to increase the pressure that we are applying on the standpipe to 1,500. So instead of 500, we should be keeping now 1,500 psi on the drill string, on the standpipe, which means that I'm keeping a 1,500 pressure below the back off. If that doesn't help in establishing the circulation, I would have nothing left to be done unless to fire the jar. And there is here like a very important note and a very important instructions that we should take care of. The jarring direction is normally and should be, and at any cases, unless some exceptions we will mention, in the opposite direction of the original movement. So let's say I was running in hole, I was going down with this drill string before the pipe is stuck. So in this stage, I will hammer up. So imagine I'm going down and something fell from the formation around the drill string. If I jar down, that will aggravate, that will like escalate, that will worsen the situation, that will make it worse, not solve it. So it's a rule of thumb, not a rule of, it's a golden rule. So the jarring effect should be in the opposite direction of the last movement. So if I was going down before the pipe stuck, so I should jar up. If I'm going up and I stuck, the last movement was going up, so the jar will be jarring down. So I will activate the jar to give me a down effect, and that's something to be like if you did anything else, you have no hope at all. If you did this step wrong, you are done. So what if in this case we cannot solve the problem? So we have no. So that's the last step. That's the last thing we can do in this situation. So what if we did all what we can, all what we mentioned, and we cannot solve the problem yet? This is out of the scope of the sessions, but we will say what options we have. So we have three options. One, continue trial or repeating the trials, continuing working, increasing the pull-up, increasing the parameters that I'm working with a little bit, like continuing in the frame trial. That's the first option I have. The second option is backing off or back off, unscrew the string above the free point and fish the leftover. And the third one is to back off or cut the string and perform a side track, like abandon this hole and drill another hole from above. So either I will continue trying or back off, cut the string and do the fishing operation, or cut the string and place a plug and sidetrack the wheel. And that's a decision that has a lot of variables. And normally there is a decision tree to guide the operation team to what decision they should take. So if we are lucky and the pipe got free, we rotate, we'll establish the rotation and clean the hole totally before continuing tripping out of the hole. So cleaning the hole, meaning like circulating the whole volume of the hole, circulating all the volume of the mud once, twice, or third. We call it bottom up or whole volume, like circulating the whole volume. So we keep circulating until we have no cutting or an acceptable level of cutting at the shaper. So making sure that this problem will not happen again when I run in hole again. So I should make sure if I solve the stuck problem, I should make sure that the hole is clean before continuing operation, tripping up or continuing. So now this is the first action that we're gonna refer to during this section, which is the induced or solid induced stuck buffer. So our first section, and as we said, we have 8 types or subcategories below the solid infused backup. The first one is the unconsolidated formations. So in this type, I have a loose formation that is not bonding very well. So while drilling, as we will like discuss later, these loose solids can fill in and cause a problem. And this is the first type, uncontrolled, unconsolidated formations. So the solids will fill from the unconsolidated formation, accumulating around the drill string, causing this type. So it happens normally in the shallow, while drilling shallow formations, which lack an overburden weight that keep it together. So commonly happen while using the shallow sections. How to prevent this type of happening? So we need to build the build-up rate slowly. We need to drill relatively slow to allow the filter cake to be built and to be in a good condition. And the filter cake, for those who don't know, and that's a new expression, the filter cake is like a thin and impermeable like sheet or like liner that I build using the mud while drilling to prevent the fluid from invading or invasion or being lost in the hole. So in the case of loose formation, I need to slow and give the filter cake the time to be built and to be in a good shape. So how to prevent the unconsolidated formation stack type? To build low permeability filter cake and to give it the time to be stabilized, which will use which will prevent the seepage losses or the minor losses to the loose formation, which will like worsen the situation. And we should avoid circulating or long circulating time against this formation. So imagine I have a loose formation here and I stopped here and I keep circulating against this loose formation. What will happen? The formation will be washed out, and that's something I should avoid. So as we said, we should give the mud the weight to soak and build a good filter cake. And I can use an additional viscous spill to be spotted against the loose formation and give it time to be soaked and form like a barrier or like something to hold this loose formation and loose solid from going in the wind. So, and I also should avoid any sudden like movement. Imagine that I'm violently or rapidly stopping the rotation and initiating it. Imagine stop suddenly or sharply bleeding off the pressure and applying the pressure. What will happen here? that will worsen, or like it will induce the formation, the loose formation of interim. Imagine that I'm like hitting the with the drill pipe the walls of this loose formation for applying or relieving a sudden pressure. It's like I'm inducing it to enter the well. So that's something I should avoid. And as we mentioned at the first step, we should build or drill the build-up rate. We should drill slowly and allow the filter cake to be built against the suspected zone. So we should not rush. We should not drill fast in this zone, because if I drill fast this zone, meaning that there is no filter cake was allowed to be built and to support these walls. So that's something I should not do. And also I should minimize the ECD and the loading of the mud, and that's also will happen by drilling slow. What's the meaning of loading? The loading is each feet I drill, each foot I drill here, it produces cuttings, and these cuttings will continue building up and continue suspending and loading in the mud and lift it up to the surface. So I should not load the mud with a lot of cuttings. And in turn, that will also will not increase the equivalent circulating density that much. So this is also a new expression, equivalent circulating density, which is the total or the equivalent density that the formation sees from the original mud weight, from the cutting that is produced while drilling, from the friction that's happening while pumping or while circulating. So that's the total equivalent of the weight or of the mud weight or the density that the formation sees. So as more as I load the mud with drilling cuttings, the higher the ECD will be. So that's something I should not do. And also, it's recommended to use sweeps, and the sweeps is a high weight pills, and sometimes it's viscous pills, or it could be both, that used to clean the hole. So after drilling, like one string, two strings, I sweep the hole, like adding a pill that will act as like I'm sweeping the hole, like cleaning it from the cutting. And that will prevent such cutting from accumulating and causing a problem. And also, drilling the unconsolidated formation, I should be prepared and ready to leave a lot of cuttings at the surface. So as you see in the normal formation, I have a regular hole size. In the unconsolidated formation, I have bigger than normal size, which means more cuttings will be produced. It means more cuttings should be handled at the surface, and I should be prepared with to receive such cuttings. And also, we should not, as we said, we should not circulate or stop for a long time here, and we should not also increase the flow rate than the required to clean the hole. So any excessive flow rate will worsen the situation. And here is an example of a method used in the North Sea to solve such a problem. So the practice said you should drill 10 meters and pull out with the string and wait for 10 minutes before continue drilling. Then go down again, and if there is a fill of the hole, if the unconsolidated formation keep like producing or pushing cuttings in the hole, that means the hole will be filled, relatively filled. So you will sense and know that the hole is giving you cuttings, that there is unconsolidated, there is an active unconsolidated formation here. So to take care of it and give it more time to stabilize before drilling further and having a problem that you cannot solve. So drill 10 meters, pull the string out of the drill formation and wait 10 minutes, then go down again. If you have a fill, so you need to pull out and give the formation more time to be stabilized. So since this situation can't be avoided, we can prevent it partially, but in sometimes we cannot avoid it. So we need to be cautious and give the formation the time to stabilize. Now to the direct indications. How can I know that I have an unconsolidated formation? First of all, I should know from offset wells. That's something like it's a basic thing to know what happened in the previous well, what happened in the nearest well drilled in the area, and I should have some knowledge about what I'm expecting. So other than this, there is like some direct indications that I'm having a problem or unconsolidated formation problem. The first is the rough drilling, like I'm not smoothly drilling. There is like a vibration. There is, as we'll mention later, there is increase in the torque, increase in pull up weight while pulling up. And as we said, any restriction in the flow path will be reflected as back pressure or pump pressure. So I'm pumping, so I'm having like 500 psi on the pump, normal circulation. In case of any restrictions happen here, this pressure will be increased since there is more resistant to flow. So increasing pump pressure is an indication that I'm having a problem. Fill on trips, like as we said, if I drill the section, then go up, while going down again, I have a fill. Like I've drilled to 1,000 meters or 1,000 feet, but I'm touching the bottom of the hole now after the trip at 950. That meaning that I having a 50 feet of fill. The solids fill up 50 feet. That meaning that I'm having an unconsolidated formation problem that I should take care. That one I should take care. As you said, in the rough drilling, meaning that excessive drag and excessive torque. And the drag is the resistance of the moving up, so or down actually. So the drag is the resistance of moving the string up and down. So if I'm while pulling out of the hole, I having a resistance, which is known as drag. Or while rotation, I'm having a torque, meaning that I have a resistance to the rotational movement. So that means that I'm having a problem. And also, if I have the shaker blind off, meaning that there is a lot of a larger than expected volume of cuttings at the shaker, that means that I have a problem. And also the mud losses, that's why we said we should use mud loss circulation loss material to prevent seepage losses. And also the shape of the cuttings that I receive at the shaker. The cutting, if it's like cave-like angular, it has no bit mark on it. That means it's not drilled. The drilled cuttings have marks on it. You can tell that the drill touched this piece of formation. But in the unconsolidated formation, the cuttings is not produced by drilling. It's just fill in the well. So you will have a cavings at the shaker, like blocks with no bit marks on it. And I will give the moderator a field pictures of the two situations, having cavings or non-drilled cuttings and drilled cuttings. Please just remind me, and I will send it to him, and he will post it to the WhatsApp today. As you said, there is a resistance while pulling up, over pull after connection, and commonly in the connection there is a stationary time. So I'm making a connection, meaning that I will stop for a while for adding a drill pipe or removing a drill pipe. So while in the stationary situation, while there is no movement or there is no circulation, if I, after taking the connection and trying to pull up and drill again, if I have an overpull here in this situation, meaning that I have an unconsolidated formation that is filling around the string. So imagine there is no fill here, and I'm drilling, and I stop to take connection. If after the connection, I'm like picking up the string and there is an overpull, meaning that there is a resistance of the movement, meaning that there is something wrong happening down there. And how we free the unconsolidated formation situation? We commonly, not commonly, the recommendation is to follow the first action, the general first action, as we said, the 9 steps we mentioned before. But noticing that in the shallow drilling or in the relatively or the very shallow drilling or the very shallow holes, the 500 psi or 1500 psi cannot be achieved or may not be achieved. So you will work with what you have then. So if you can't achieve the 500 or the 1500, you will work with what you have. You will work with the maximum pressure you can hold in this situation. So this is the first type. And now the mobile formation. And also do not expect, I know I take a lot of time explaining this, and please type in the chat. If I'm talking a little bit slow, if I'm talking a little bit, you need to like speak a little bit faster, speak a little bit louder. Just keep engaging in and tell me what should I do? So I will not move on unless you tell me, is it a good pace? Should we continue that way? And I'm expecting that the speed or the pace of the speech will be a little bit faster in the next type, since we know now most of the abbreviations and most of the expressions. So I'm waiting your comments. Hello? Hello? Okay, we need more feedback, please. Do you need to change anything? Okay. So speak faster, and that's it? Okay. That's great. Okay. So the second type we have is the mobile formation, and this type of the formation, it has the ability to move in a plastic way under the pressure. So under the pressure, so, sorry. So a mobile formation, it's squeezed in a plastic way under the stress, which leading to restricting the annulus and the flow. So and that's normally because there is insufficient mud weight to support these stresses. So it's normally happen in the salt and shale formation, which is the plastic formation, and commonly happen with the salt and shale formation. So what should I do to prevent the mobile formation from entering the well core? So sufficient mud weight to support the formation stresses. An appropriate mud system should be selected not to aggravate, not to like worsen the swelling or the movement of the formation, to prevent or inhibit such action. And also, a wiper trip and reaming operation should be designed or planned. And the wiper trip is like gauging the hole, like pulling out of the drilled hole and running in again to make sure that all the hole are engaged. There is no swellings, there is no ledges, there's nothing wrong with the geometry of the hole. So that's what a trip, a wiper trip means. And reaming, like in the reaming or back reaming, I have like lower parameters, lower drilling parameters, and like repeating or running in hole again, like doing it again, like making sure that the wheel are in shape. And the reaming and back reaming should be cautiously performed, since the like 60% of the stuck pipe problems are followed or caused by reaming and back reaming. So that should be taken care of, that should be cautiously performed. So and also should trip in and trip out in a slow, relatively slow pace, not to hit or not to stuck, like slowly tripping in to sense any changes in the geometry. So if I'm slowly tripping, if there is anything happen, I will feel the hang of, I will feel the hang of the drill string, and I will stop and pick up again and solve the problem. If I'm running in fast, I could like jam the drill string against the mobile formation. Also, the swelling or the mobile formation increased as the exposed time increased. So as long as this formation exposed to the mud, as or the larger or the severe the problem will. So the faster or the shorter the exposure time is, the better for the mobile formation. And while drilling in salt formation, I should consider, and that should be done cautiously using undersaturated mud system, meaning that if this mobile formation is salt and I'm using undersaturated mud system, that means some of these salty formation will be dissolved into the mud, meaning that I will solve the problem while drilling. That the problem will not happen at the first place, but that something should be cautiously done and should cautiously calculated not to wash out the formation. So if it was undersaturated with a wrong margin, that means that more salty formation will dissolve it in the mud, causing another problem, which is a washout. So our rig side indications, as we see here, we're expecting an overpull while pulling out, and as we said, overpull, like it's a resistance of the drill string movement, and also having a weight while running, meaning that the drill string is hanging against something. So if my weight is 50 pound, 50,000 pound, the drill string weight is 50,000 pound, and I'm running in, and suddenly against this formation, the weight become 40,000 pound, meaning that the string is hanging against something. So that's an indication that I have a mobile formation here, or like a ledge or something here that I'm hanging against. And so also the sticking like something sticky, sticking of the BHA could happen against the mobile formation. It's also will be indicated as an overpull or a resistance of move of the drill string movement. And it's normal that if the formation is swelled or moved in, restricting the flow path, meaning that I will have a restriction of circulation, and that will be indicated on the surface as an increase in the pump pressure. How do we freeze this type of stuff? In salty formation, we apply a fresh water pill, and as we said, it will dissolve the salt or the salty formation and remove this part, and that should be cautiously considered and calculated not to wash out the formation. In the shale, if I have a mobile shale formation, if I was moving down, moving up, sorry, we will apply the torque on jar down. As we said, it's our golden rule is the jarring direction is in the opposite way of the last movement. So if I was moving up and I got stuck by it, I should apply the torque and jar down, and vice versa. And there is a note here not to apply a torque while jarring up, and this has like a safety consideration. If I'm jarring up, oh, let's not to sidetrack. Okay. So the third type of deformation, or the induced deformation type is fractured and faulted deformation, and it's commonly used while drilling around or through faults. So the faults has like a fractured pieces of rock, and if I'm drilling through the fault or around it, these broken rocks will fill in the well and causing fracture and faulted formation type of stockpile. So I will notice it as an increase in the torque. It happens commonly in the fracture formations like limestone, or in the area with a high tectonic activity. And things to be done to prevent the fractured formation type of stock, to minimize the vibration of drill string. And it makes sense that if I have a broken or fractured formation here, if the vibration is high, I will keep hitting the walls and causing these rocks to be fill in the way. So, and also changing the revolution per minute, which is the speed. Abbreviation station have this. So I should change or alter this speed, slow down, or change the configuration of the drill string to minimize the choke effect. Also, anything that will cause a shock or hitting of the formation, I should avoid. In a high speed, so I should not do so. I should slowly trip in or trip out.
Excuse me.
Yes, go ahead.
Could you turn off the sound, the video camera, because the sound is not very clear?
Yes, I will do so.
Okay, thank you very much.
Okay, and please interfere if any things going wrong. And thank you for interfering. And please comment in the chat box if there is anything wrong. The fact so as we said, we'll restrict any vibration, any shock on the formation. So this any sudden applying or relieving pressure should be avoided. And we also should consider reaming against the fracture zone. And as we said, reaming is like re-drilling. I have a drilled hole, I'm just passing through it again with the rotation and flow in to like make sure that everything is okay. It might be with different drilling parameters, but like I'm as if I was drilling the hole again or this section again. The indication, of course, I will have a fill, and we know now what the fill meaning. So after the connection, running hole again, I will have a fill as a result of these broken rocks filling in the hole. So if I have a fractured formation, I could imagine or anticipate losses or gains, depends on the pressure regime of the formation, since it has an already high permeable zone. So if there is any pressure difference between the mud in the well and the formation pressure, I could expect either losses or gains. And if that happens, meaning that I should or combine with other signs, I should expect that this is a fracture or faulted formation. And also, as we said in the unconsolidated formations, that the shape of the cuttings on the shaker matters. So the produce the rocks from the fault is in the cave formation, and both of them are different than the drilled mud. The drilled cuttings. And I will add also how to differentiate or how to tell from the look of the cuttings what's going on down there. And I will forward some pictures to the moderator to post them on Facebook. On a WhatsApp. And also sticking could be expected since I have a fill. So as we said, sticking like an instantaneous stallment or stop in the movement, and that should indicate that something wrong is going on. How do I freeze on? How do I through this type of the stuck pipe? I follow the first action, the 9 steps that we mentioned. If that doesn't solve it, I should jar up to break or to like move these debris. And as we said, that our golden rule is it moving up. Is jarring. The jarring direction is in the opposite of the last movement, unless or is an expectation, as we say, exceptions. Sorry, as we said in the intro. So that's one exception. Here I will jar if I have a fractured or fault formation. I will jar up. And also I should make all the efforts to continue or to regain the circulation, since gaining circulation meaning I will have the ability to clean this broken pieces and bring it, clean the hole and bring these cuttings to the surface. Putting an acid against a limestone will do the same effect as the fresh water with the salt. It will dissolve some of these rocks, solving the problem if I'm against a limestone. And also spotting high vis fill will help in carrying up it will has a higher carrying capacity, and it will help in carrying up these broken rock pieces. So the next type, which is the force, and there is a lot, there is many, or they're almost identical with the next step, sorry, with the next type, the naturally overpressure chain and induced overpressure chain. These are the next two types. So the naturally overpressure chain is shale formation that's naturally charged, it's overpressure, and its pore pressure is greater than the adjacent formation for many that out of the scope of this course. But you can search about it. There is the under compaction could lead to this situation. The naturally removed overburden could cause it also. And I don't want to go into detail pressure for natural like form it, but you can search it. So I have a shale formation, and it's naturally overpressured. It has a higher pressure than formations, and the shale, as we said, is brittle, like it could be broken, like the it's not an elastic type of rock. It could easily be broken. So it's pressured formation, and its ability to be broken is high. So in case of drilling such formation, and this formation, if the mud weight is not adequate to support or to counteract the formation pressure, this formation will be broken and fill in the well. So, and I should expect such problems in the rapid depositional shale sequences, and this is also an expression and something that I don't want to go in details, but it happens or form it when the depositional environment at the very beginning of the rock layer formation was rapid, so there's no cementation between them, so between the rock matrix, and with other parameters that lead to formulating such layers. So if I'm expecting, or if I know from the seismic or from offset wells, the near wells that is drilled, was drilled or were drilled in the area that I'm going through a rapid depositional shale sequences, I should expect having an overpressure shale, and expect that could like make a problem. So the prevention, I should have a sufficient mud weight to support the overpressure. I should minimize, also as we said in the previous type, I should minimize the exposure time, the time that these formations are exposed to the mud. So as short as the drilling time, as less as the problems. That doesn't mean that I should speed things up. No, I just should be like effective and optimize operation, not to spend a lot of time drilling such formation. And I also should use the gas level in the mud as an indication of any invasion or any increase, as an indication of the increase of the drilling of the pore pressure. If I don't have other means And normally, I have other means to expect or to measure the pore pressure, like pressure while drilling. If I don't have so, I could rely on the percentage, the gas level in the mud. That means if I have a higher gas level and the formation was has naturally has gas in it, so that means that the I have more cuttings in the well, meaning that more gas percentage in the in the mud. So I should use this as an indication, and I also should verify and predict the or make efforts in predicting surprised with an increase in the pressure. And also, it's highly recommended, and that's something we should not do. Highly recommended not to do so, and that's something we should be vigilant about it. That we should not suddenly or decrease the mud weight. Not, if I'm drilling in this section, I should not reduce the mud weight for any reason, since that will induce this formation to be broken and fill in the well. So the rig site indication, and of course the cavings, and in this way splintery cuttings at the shaker, meaning that the cutting itself has like a sharp edges, meaning that it's like it's bob out of the formation. It has sharp edges. It has no drilling marks on it. It means that these cuttings did not been drilled or had not been drilled. So they are, we call it splintery, and you can refer to the refer to it in the images that I will share on the WhatsApp group. And as we know now, any fill in the well, any cuttings around the drill string will lead to increasing the torque and drag. And as we said, increase the gas level and the pore pressure profile. And also any restriction here will restrict the circulation and increase the pump pressure. And of course, I will have a fill after the connection or after pulling out of the pump. And also the last part is very like detailed, and there's something that will tell you what's going on down there. So the cutting and caving, the cutting that we are receiving at the at the shaker are not hydrated or mushy. So that means it's freshly produced cuttings. It long interacting with the mud. So when the shale or when the cuttings, caving cuttings, when the cuttings is drilled, it has like some more time of exposure with the mud. So its surface, its outer surface will be hydrated. It will be like a little bit soft or mushy. But with this with the overpressure cavings or shale caves, it will have no hydrated surface, nor a mushy or like a soft texture. So that means it's freshly produced. It has no time, no long exposure time with the mud, and that's an indication of an overpressure formation, natural overpressure formation. And of course, we cannot take each indication separately. we should have a look on the whole picture. This with that, with that, with that, that each one will support an expectation, a certain expectation. So in sorry again. So the freeing mechanism is to follow the first actions that we mentioned at the beginning. The induced overpressure shale collapse, it's similarly the same results of the previous type, but in this case, we are the reason of overpressure. It's not naturally over how we overpressure the shale. And over we commonly or conventionally drill with an overpressure mud weight, meaning that the pressure of the mud in the well is higher than the formation pressure, and after a certain exposure time, this formation, the shale formation, has low permeability. So the pressure will keep building up or communicating with the pores, but it will take its time to do so. So with certain or adequate time of exposure to high pressure, the adjacent matrix or rocks to the well pool will be overpressure. And at any instance, if the lower is lowered for any reason, that meaning that the shale now is overpressured and now have a higher pore pressure than the weight or the well pool, meaning that it will lead to the same results. The shale be collapsed to the well pool. So in this case, we are the reason to do so. And we shouldn't do so, of course. So it happens normally drilling with water-based mud after reducing the mud weight for any reason, as we said. We charge the formation, then we reduce the mud weight, so the formation reacts and fill in the well. And as we said, the charging the formation take time. So if I allow the exposure time to be long enough to charge the formation, that means it will be overpressure. So after a long exposure time, that situation is more probable to happen. And in the casing rat hole, it's also related to the previous one. The rat hole is the hole that is normally or that's left behind below the casing. So I drill to that depth and I install or place the casing at that depth, and the cement job. So there is a so it's commonly have water based mud or any other. Do not plan to reduce the mud weight. We should not reduce the mud weight, not to start the caving or the breakdown of the formation. And we also should have a good wheelboard cleaning practice. So this situation should not escalate to become a stuck. So if I have a good whole cleaning practice, I will clean up the hole gradually, and no cuttings will accumulate, leading to a stuck situation. So our indications now, we know what we are expecting. Cuttings and cavings with no hydration and no mushy exterior. Splintery cavings at the shaker, as we said, splintery like having sharp edges with no drilling or bit marks, means that it's not a drilled cuttings. Tight hole in casing rat hole, meaning that the rat hole that left below the casing is tighter than expected, meaning that I have something entering the well. And of course, I will have a torque and drag and the normal expected signs, which is increase in the pump pressure due to the circulation restriction. And I will have, of course, a hole fail. And it's almost the same as the previous one. And I prefer to stop here, not to lose your focus. I suggest so. We have a total of 80 slides in this course. So we have now, we done now 34 slides, and I think the rest could be covered in the next 2 days. And I give you some time to like study the new expressions and read more about what we have mentioned. And the floor is now open for your opinion. Should I continue or should I stop here?
The mic is now open to you, Lester.
Pleasant good day, my brother. You can hear me?
Yes, I can. Yes, I can. Go ahead.
Okay. Good presentation. But let me ask you a question.
Yeah, sure.
Is there with all that you now explain with the different types of collapse and the different types of formation that contributes to stuck pipe, is there any special type of additive to date that can be added to drilling mud to prevent such type of stockpipe?
Okay, thank you for your feedback and thank you for your question.
Mm-hmm.
Yes, there is some additives and also selecting the proper mud system will prevent the development of almost all the problems. So, in case of selecting the proper mud weight, and as you see now as we're talking, like most of the problems happen since the mud weight is not adequate. Some of them happen because there is a long interaction or exposure time with the mud system, meaning that the mud, as long as it interacts with the formation, there's something is happening. So what if I optimize the mud weight that I'm using to give me more time room of drilling time exposure or more exposure chance? That meaning that will reduce the probability of developing such problems. So yes, there is a lot of additives, and mainly the mud is like the bloodstream of drilling. Optimizing it and choosing properly will alleviate almost or prevent almost all the problems. There is, as we will mention later on, there is an active formations that react with the mud, a certain mud types. So drilling without additives or inhibitors to prevent such interaction will allow the problem to be developed. So the answer is yes, but of course I'm not fully aware with the mud additives since it's like a separate speciality or a separate area of speciality. But yes, and there is a lot of tests. If I have previous cores or cuttings from previous wells, there's a lot of compatibility tests to be performed to see if this type is compatible with the formation or not. So the answer is yes.
Now Engineer Sami can say his question.
I'd like to ask you about if there is a PDF for this lecture to study it, and thank you so much.
Okay. The PPT itself, I cannot perform or not, I cannot produce or share a PDF from it, but I will share more informative material with more information that you should study, and if there is any thing that you cannot follow or you cannot understand, we can discuss it in the next session. So I will share a PDF, but not for the presentation, but for more detailed and informative references. Yes, next question.
Another question. What is the on any site, whether it be onshore or offshore drilling rig, and this question is applicable to what we're discussing here. Where does the communication start and ends between the driller, the drilling engineer, and the mud engineer with respect to identifying and preventing these scenarios from happening? Because these things could only be limited to communication by all parties involved, right?
Yeah. So we have different levels of communications. The rule is 24-hour of communication is performed, but we have levels. First of all, the drilling program. It should be like collectively created, revised, and communicated between all the parties. Drilling rig or the drilling contractor and the crew, the service companies, and the operation or the operator company, including their own drilling engineer, their own mud supervisor, their own drilling supervisor. So the drilling program itself is created collectively. So we all are participated in it, and we all know all the parties in it. So that's the first level. The second level is the pre-spot meeting. And the pre-spot meeting, in the pre-spot meeting, all the included parties are presented, and each person or each section, a representative of each section, explain what's going on, what we are about to do. So and there is a room, or the floor is open for discussion and question, and even a feedback we have in the pre-spot meeting. And we have a pre-spot section, a pre-section meeting. Before each section, each whole section, we have a meeting. We will communicate what happened, what will happen next, and what we did already, and how to benefit from what we the mistakes we did in the previous section, and how we can avoid it, and how we can improve the performance. And we communicate all the technical details, and also all the parties will be involved. And it's commonly take place in the meeting room in the rig. So we have also a daily, two daily operating meeting. We have one at the morning for the morning shift, and one at the evening for the evening shift, or the night shift. And in this meeting, all the parties, all the stakeholders, all personnel, or all the key personnel or involved personnel in the rig should attend, and we communicate what we are gonna do, what we are expecting, what we are doing, what we did wrong, and how we benefit from it, and we take suggestion to improve or to do better or improve our performance. So in addition, there is a job instruction for each job. So each job performed, it has its own instructions, and that is printed out and distributed among all the parties that will be involved, so we all know what's going on. And also there is a 24-hour communication between the driller, service company, and rig supervisor. We are all in the same place. We have a continuous communication with the office. The operator has a well site drilling engineer on the rig. Mostly they have a well site drilling engineer, and he work like actively in a collaboration with all parties. So a high level of communication is guaranteed, and that's a must. The communication is a must. I hope that I've answered your question. Okay. Yeah, sure. And just said, wanna add an answer for the question? Yeah, go ahead. Yes, Inj Magdi Ragab, I think, or Said Magdi Ragab. Go ahead. And meanwhile, you are typing the answer or adding an answer. I will answer Inj Akram. Does the most common reason related to the mud, or there is another? Of course, there is another reasons. As we said, there is a naturally fractured formation. There is characteristics of the formations already that like you are drilling an already challenging formation. So the human factor is the major player here, but also the characteristic of the formation itself and how efficient the mud design play a great role in it. So any questions? Any more questions? Okay, Jahadi, if you have
Yes,
like
with you.
last
Uh,
words, I'm done.
Finally, thank you, Engineer Husseini, for this great session about stack pipe. As you discussed some main topics about hole back off, unconsolidated formations, fractured deformations, pressurized shale, and so on. I hope the attendees have benefited from Engineer Husseini, his experience in drilling engineering. Thank you all for your time with us.
Thank you.
Hello?
Yes, please. If you have any question, ask him.
Hello? You can hear me? You can hear me now?
Yeah, I'm here. You.
Yeah, this is Magdi Ragab. First of all, I would like to thank you as well as Mr. Husseini for these topics regarding about stock. I asked to just add some answers regarding to what Lester's asking for. And I will just summarize what Mahmoud said as on actual. We are doing on actual regarding about design for our wells and phases based on the problems or historical data and classified as BHA design, mud design, and also in the same drilling program and in each phase meeting, we also discuss with the surface company about the proper BHA design using well plan. And also in this well plan, we can easily make torque and drag road maps. And based in this roadmap, we not only focus on the one type of stock, we focus on all types of the stock. Based on this torque and drag roadmap, we already supplied to the drillers and as well as drilling optimization team, which is related in sometimes to surface company, which is direction company, or sometimes a third party like Merlin company. And we use this torque and drag roadmaps, and it was so efficient, especially while drilling in high angle wells and ERD wells. As Mahmoud said, and also for listeners, we mainly design for the proper mud program, selecting the proper mud weight, proper mud type, proper additives we can do for that. And one of the most important parameter we should to look at and highly affect the performance of whole cleaning and also affecting the values of torque and drag is ECD, which is ECD management, one of the most important topic. I think maybe Mahmoud will add more for that in next 2 days regarding about how to manage ECD management and also drilling dynamic management.
Okay. Firstly, thank you so much for your summary, for your great summary about what did you learn today from Engineer Mahmoud El Husseiny. Can you send me this summary to my private number? You can see my number in WhatsApp group, okay? And I'll send it to Engineer Mahmoud El Husseiny. And finally, thank you so much for your participation in this session. Thanks. Thanks, Said.
Thank you, Hadi. Thank you. Sure.
You're
Thank you.
welcome. You're welcome. Anybody else has any question?